Under BELG 2433 Electrical System Subject from Group 6, we would like to present about the power generation in electrical system using nuclear. So, what is nuclear power generation? Nuclear energy stands out as a highly efficient and reliable method for producing large amount of electricity, harnessing the power of atomic reaction to generate waste energy output with minimal fuel input. Unlike fossil fuels, which contribute significantly to greenhouse gas emission, nuclear energy does not release carbon dioxide during its process, making it an environmentally friendlier option in the fight against climate. As a cleaner alternative for meeting the world's growing energy demands, it reduces reliance on polluting sources while promoting sustainability. Furthermore, nuclear power plant can supply stable and uninterrupted electricity to national grids worldwide, operating continuously for extended periods and provide baseload power that support economical growth and energy security.
Construction and component. Nuclear plant is built with a strong reactor building that safely contains a reactor. Inside it, the reactor core holds the uranium fuel rod and control rods to control the fission process. The coolant system carries heavy heat away from the reactor to produce steam. The steam is sent to the turbine, which spins the generator to produce electricity. After that, the steam is cooled in a condenser and turned back into water. The plant also includes cooling towers and control room to monitor all operations. Operation. A nuclear power plant begins its operation inside the reactor core where nuclear fission phase. Uranium fuel rods are arranged in bundles, and when the uranium atoms split, they release a large amount of heat energy. Control rods made of neutron-absorbing materials are inserted between the fuel rod to regulate the fission process and keep it stable. A coolant, usually water, constantly flows through the reactor to absorb the heat produced, preventing the fuel rods from overheating. This heat is the foundation of the entire electricity producing process.
Now I'll be explaining about the steam generation and electricity production. The heat carried by the coolant is transferred to water in a steam generator or is used directly to boil water inside the reactor. This creates high pressure steam that is directed towards a turbine. The force of the steam rapidly spins the turbine blades, converting thermal energy into mechanical energy. The turbine is connected to a generator, and as it rotates, the generator converts the mechanical motion into electrical energy. This electricity is then sent to transformer and the power grid. Thirdly is the condensation, cooling, and recirculation process. After the steam passes through the turbine, it flows into a condenser where it is cooled and turned back into water. This cooling is done using water from river, sea, or cooling towers, depending on the plant design. The condensed water is then pumped back into the system to be heated again, treating a continuous and efficient cycle of steam production and reuse. Excess heat from the plant is released safely through cooling towers or discharged through a controlled cooling system. This final step ensures the plant remains at safe operating temperature while maintaining a steady supply of electricity.
Now let's look at the requirements. Nuclear power plants have multiple safety systems to ensure safe operation. Continuous cooling systems circulate coolant around the reactor core at all times to remove the huge amount of heat produced during fission. Radiation shielding using thick layers of concrete traps radiation inside the reactor building, protecting workers, land, of the environment during accidents. In case of an emergency, SCRAM systems allow control rods to be dropped instantly into the reactor core, stopping the fission reaction immediately. Spent fuel is carefully managed by storing it in deep water pools that cools it, and later transferred to a dry cask storage. Finally, nuclear plants follow strict regulations and undergo regular inspections, checking reactors, cooling system radiation levels to maintain high safety standards at all times. Some examples of nuclear power plants that are currently in operation include the Kashiwazaki Kariwa nuclear power plant, which is in Japan, and it uses boiling water reactors, and it is one of the largest plants in the world, supplying electricity to the regional grid. In the US, the Watts Bar nuclear plant in Spring City uses pressurized water reactors, actively producing electricity for the region. And then in South Korea, we have the Wolseong nuclear power plant, operated by the Koryo Hydro and Nuclear Power, which uses CANDU heavy water reactors and is fully operational, providing a significant portion of the country's electricity.
As a conclusion for this presentation, nuclear energy offers high efficiency with lower carbon emission, which can save our environment. And then nuclear energy remains one of the most powerful and dependable source for sustainable electricity and supporting long-term energy security.